Alright guys, so let's take a look at the next simple machine that we have. This one's pretty straightforward. These are pulleys. We have movable pulleys and we have fixed pulleys. So this is a fixed pulley right here. Basically you have a pulley that's fastened at the top here. And then this pulley here, if you extend this out and you're pulling up, you have a movable pulley. So fixed pulley is mounted, and all a fixed pulley does is transfer the direction of the force. The distance doesn't change, nothing changes. So if I've got a load down here of 10 pounds, I still have to pull down with 10 pounds of force. Okay, so nothing's very different right there. Now on a movable pulley, because this pulley is fixed in the middle, and as I pull this up, this pulley is going to travel upwards as well. And basically the pulley should go about half as far as I pull my string. Remember, I'm trading distance, I'm using less force but using more distance. So basically on a movable pulley, the ideal mechanical advantage is how many strands it has. So here's one, here's two. So this has a mechanical advantage of 2, okay? Because basically you're spreading this load, this 10 pounds, over the two different strands. So as I pull this one up, it's going to go twice as far as the pulley goes up. So the pulley, if this one goes 5 feet, the pulley is only going to go 2.5 feet, okay? Because it's got a mechanical advantage of 2. Okay, so it's pretty straightforward. Now, if we look at pulleys in combination, you have basically down here you have some fixed pulleys and some movable pulleys. So what are we going to do? What is the IMA of the pulley system on the right? Well, what are we looking at? We've got a movable pulley here, and we've got 1, 2, 3, 4 strands. So we have 4 strands, so we have an ideal mechanical advantage of 4. We also have these fixed pulleys, so these don't do anything. So we're basically just looking at these two, and they have a mechanical advantage of 4. Now if we have this guy here, what is our mechanical advantage here? Well, we've got movable pulleys and fixed pulleys. So this guy right here has a mechanical advantage of what? 1, 2. So we have a mechanical advantage of 2. This guy right here is a movable pulley that has a mechanical advantage of 2. And this guy right here has a mechanical advantage of 2. So what we're left with is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So we have a mechanical advantage of 8. Here we have mechanical advantage of 4. Okay, now these are ideal mechanical advantages. So the actual mechanical advantage is going to be the same thing. You have the force of the effort over the force of the resistance, and you should be good to go. Okay, so this one's split into 40, 40, and 10, or 40, 20, and 10. Okay. So what is the actual mechanical advantage of this pulley? Well, we know the actual mechanical advantage is force of the resistance over the force of the effort. Well, what's the resistance? This is my resistance force, and this is my effort. I'm putting 230 pounds in to lift this 800. So the force of my resistance is 800 over my 230 pounds of effort. And that equals 800 divided by 230. That equals 3.48. So 3.48 is my actual mechanical advantage. And then what is the efficiency? So I had 3.48 of AMA. The ideal mechanical advantage was what? 1, 2, 3, 4 strands. So IMA was 4. So what is the efficiency? How do you find efficiency? Well, whoops. Stuff all, oh no. Needs to go back. I'll bring that slide back. There we go. So efficiency is AMA over IMA. So AMA of 3.48 over the ideal mechanical advantage of 4. So we have 3.48 divided by 4 and that gives us 0.87, which is equal to 87% efficient. Okay, so there's your efficiency. So those are pulleys. Pulleys are pretty straightforward. If you have a fixed pulley, there is no mechanical advantage. Doesn't matter how many you put on there. If you have a movable pulley, you have the number of strands is your ideal mechanical advantage, and then to find the actual mechanical advantage, you have to actually put weight on it, lift the weight, and measure how much force is in and versus how much force is coming out. So basically, that should take care of pulleys, and that should be the end of this video.